All right, so here we've got sec to the power of 4x. If we just have a little play with that, we know that sec squared x times sec squared x. And if I break one of those into 1 plus tan squared x, because I like a mixture, and we've got sec squared x there. So you can see we're just going to get a sec squared and a tan squared sec squared. And that's nice, that's what we want. So if I break that first integral, 0 pi on 3, into a sec squared dx plus 0 to pi on 3 tan squared sec squared dx. That should make it easy to integrate. All right, so sec squared we know just integrates to tan x, so that's nice. That's just tan x. We could do it this all in one actually. And as long as we got the derivative here, the derivative of tan is sec squared x, so we can just integrate the tan part. So if you think about it, we're doing a substitution where u is tan x, so du is sec squared x dx. So that second integral is just becoming u squared du, so it becomes u3 on 3. And u is tan x, so tan cubed x on 3. So that is between its definite integral, pi on 0 and pi on 3. So if I put 60 in, so pi on 3 is 60 degrees, tan 60 is root 3. So what do we have? We have a root 3 plus a root 3 cubed, so that's 3 root 3s. And that cancels there. And then minus, if I sub a 0 in, I just get 0 and 0, because tan 0 is 0. So what do we have there? We have 2 root 3 as our answer. All right, so I'm just going to write that here. So remember, this is 2 root 3. Okay, so what if we have sec to the power of 6? Well, again, we can break that up, a little bit. So let's have a look at sec to the power of 6. Sec x to the power of 6. If I break it up into sec squared x and sec to the power of 4x, and sec squared, let's make that 1 plus tan squared x sec to the 4x. There we go. So you can see if I break that up, it's going to have sec to the 4x, which we did in A, so that's nice, plus tan squared x sec to the 4x. Now, I don't really want that, so I'm going to break that one up as well, just like that. So the sec to the 4x is nice, but this part I need to change a little bit. So why don't I change one of those sec squareds to 1 plus tan squared? So if I think of, that's 1 plus tan squared there. Well, that didn't work very well, did it? All right. So let me go over here. So my integral would become 0 to pi on 3. I've broken it up. First one was sec 4x. There we go, dx. And then 0 pi on 3. If you think of, let's say, tan squared sec squared, and we're multiplying it by 1 plus tan squared x there, we are going to get tan squared sec squared. Tan squared sec squared, yes, we are going to get tan squared sec squared, which is fine, tan squared x sec squared x dx, and we're also going to get, so that was from the 1 times, and we're also going to times that by the tan squared. So the third one we're going to get, oh no, we're going to run out of room here, sorry, going downhill, is tan to the power of 4x, and we still got our sec squared x dx there. All right, so now we know that between 0 and pi on 3, sec to the power of 4x gives us 2 root 3. That is from A, from our part A. We know that if sec squared x is the derivative of tan x, then this second integral is just becomes tan cubed x on 3. We've done that before. So that's between 0 pi on 3. All right, so if we look at the last one, again, we've got sec squared already. That's the derivative of tan x. So this one just becomes tan to the power of 5x on 5. That's 5 there. All right, so let's just sub that in. So we've got our 2 root 3. Again, remember tan of 0 is 0, so we don't have to worry about the zeros. Pi on 3, so 60, so we've got root 3 cubed, so that's 3 root 3, and it's on 3, so that cancels. So now we've got 3 root 3's all together. And here we've got root 3 to the power of 5, so we get, that'll be 9 root 3 on 5. Putting that all together, we will end up with 24 root 3's on 5.